Hello and welcome to yet another video of Cornerstones of Math. Today we are going to solve the following problem. Here we have this blue graph. You can easily notice that the graph is octagon, and we want to express this graph with a single equation. First, we have to think about the symmetry. Notice that the graph is symmetric with respect to both x and y axis, and therefore also symmetric with respect to origin. This tells us the important aspect of the equation of the graph. We can express this graph with a single equation, f of absolute value of x, absolute value of y equals 0. That is, all x terms in the equation of the graph are absolute value of x, and all y terms in the equation are absolute value of y. This is actually quite obvious if you think about symmetric points. If a certain point a, b is on the graph, this a, b must satisfy the equation of the graph. Moreover, these symmetric points, minus a, b, a, minus b, and minus a, minus b must also satisfy the equation of the graph. This is possible if the variable terms of the equation consist of only absolute values of x and y. So here's the strategy. First, we obtain the equation of the graph only on the first quadrant. That is, when x and y are both positive. Let us call this graph f of x, y equals 0. Then, if we take absolute values of x and y in that equation, the newly obtained equation f of absolute x, absolute y equals 0 represents the graph where the previous red graph is copied by symmetry operations over x-axis, y-axis, and also around the origin. So let us try to find the equation for the first quadrant part of the graph. The first quadrant part of the given octagon graph consists of these two linear graphs with a vertex or sharp turn at x equals 2. Here we know that these kind of graphs having sharp turns also have absolute values in their equations. In this case, since the graph has a sharp turn at x equals 2, its equation must contain absolute value of x minus 2 term. Therefore, we can write the equation as y equals a times absolute value of x minus 2 plus some other terms, where a is constant. Now what about the other terms? Since the graph has only linear parts, the equation must be always a linear function regardless of the value of x. Therefore, the other terms must be also linear. We can therefore write y equals a times absolute value of x minus 2 plus bx plus c, where a, b, and c are constants. So we have the basic form. Now, let us obtain the values of a, b, and c. This can be done by using the fact that the graph passes points 0, 3, 2, 2, and 3, 0. So using these 3 points, from 0, 3 we obtain 2a plus c is equal to 3, and from 2, 2 we obtain 2b plus c is equal to 2, and from 3, 0 we have a plus 3b plus c is equal to 0. So we have 3 unknowns and 3 equations. Solving this system of equations gives a equals minus 3 over 4, b equals minus 5 over 4, and c equals 9 over 2. Therefore, the equation for the red graph is y equals minus 3 over 4 absolute value of x minus 2 minus 5 over 4x plus 9 over 2. The equation of the entire graph of the octagon can be obtained by simply replacing every x and y in the equation with absolute value of x and absolute value of y, thereby giving it symmetries with respect to x-axis, y-axis, and the origin. Therefore, the final answer is absolute value of y is equal to minus 3 over 4 times absolute value of x minus 2 minus 5 over 4 times absolute value of x plus 9 over 2. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.